días, ¿qué tal? ¿Me veis ahora? ¿Qué tal? ¿Me veis ahora? Hola otra vez, ¿qué tal? ¿Podéis verme ahora? ¿Podéis por favor poner en el chat si me veis o si me oís bien? Porque a veces esto me da problemas. Alguien, no sé si Inés o Eva, Valeria, que estáis por ahí, ¿podéis decirme si me oís bien o me veis bien? Yes? ¿En eco? Are you? Okay, okay, good, very good. Now, we're going to start. Sorry because I have some problems about this technology. And now please go to your notes and go to your exercise part. We're going to start by correcting your last exercises in natural science. Natural science. And now you need to go to your page number. I can't remember page number 5. And maybe you remember that we were working about thermal energy. You have here this exercise about the three ways in which thermal energy is transferred. You have here eight items, and we're going to correct it. So be attentive, please, because I want your contribution. So H1. So it is the transfer of heat by the motion of a fluid. So, and you have to choose between convection, and radiation. What do you think? What do you think? Transfer of heat by the motion of a fluid. A fluid, you remember that is the name that is given to liquids and gases. And the correct answer is, waiting for you, is convection. Okay, convection is just for fluids. Number 2, thermal energy is transferred to the earth from the sun through that process. And we need to choose between convection, or radiation. 2. So the correct answer would be radiation. Good. Number 3. It transfers heat energy through gases and liquids. Through gases and liquids. These are fluids. So 3 is, in this case, convection. B, convection. Let's move to number 4. It is the transfer of thermal energy between solids. So they need to be in contact between them. Number 4, conduction, convection, radiation. Yes, conduction. Conduction is the way of transferring heat by the touch. So you need solids. Number 5, it occurs in the atmosphere and in the oceans. The atmosphere, air, gas, oceans, water. It also happens in a soup. So number 5 refers to fluids, and this is again the convection. Good. Number 6, it is a form of heat transfer that is moved from one place to another by electromagnetic waves. So no contact, no fluids, so that must be radiation. Number 7, it doesn't require a form of matter to be transferred. No matter, so no gas, no solids, no liquids. So 7 must be radiation. Okay, and finally, it continues until both objects have the same temperature. Radiation impossible, because you have to think of the sun. The sun doesn't lowers its temperature, and could be convection or conduction. So, so number 8 could be A or B. So let's move to the next exercise. Number 9, fill in the gaps with the terms for the 3 ways of heat transfer. So we need to place conduction, convection, or radiation in its correct order. So fire illustrates the 3 different methods of heat transfer. For example, the firebox will heat up due to, so this is the firebox, and inside you have fire. They are in contact. The fuel, maybe wood, inside is in contact with the firebox. So this is a solid, inside there is another solid, and the correct answer here is conduction. Good. The air, a gas above the fire, will be warm due to the air, a gas, so will be heat up due to convection. Good. And finally, you can warm your hands near to the flames due to not in contact, so radiation. Very good. So now please go to your test sections. We're going to see some video clips about that, but before we want to study that. So the effects of thermal energy. We're going to study 2 of them. The first one is that hot objects expand no matter if they are solids, liquids, or gases. You have here a picture that shows kind of ball, and here you have a ring. If you heat up this ball, this ring is too small for the ball to pass through. So when gases, liquids, and solids are heated, they expand, they get bigger. No matter if they are solids or liquids or gases. But the opposite is true. As they cool down, they contract, they shrink or get smaller. And attention, why is that? You have to think about the composition of matter, composition about particles, about molecules. This is something that is cold. Maybe this is a solid. This is cold, and as this is a solid, these molecules only vibrate, can't move. But if you heat up this material, all these molecules start moving faster and faster, and as a result, this is the first volume and this is the second one. So this is expansion of matter. So the expansion of the gases and liquids is because the particles are moving around very fast when they are hit, and are able to move farther apart, so they take up more room, more space. Now I'd like you to watch some documentaries. It's a very interesting documentary about
Matter exists as solid, liquid, and gas. All the 3 states of matter expand on heating. The expansion of matter depends on the temperature through which it is heated. In this case, when we heat this plate, the higher the temperature, more is the expansion.
So this is the first condition, the temperature. So the higher the temperature, more space that occupies this plate here. So this is the first condition.
Expansion of matter also depends on the size of the material being heated.
This is the second condition, the size. Okay? Okay? The higher, more space takes up this volume, the more expansion is occurred here.
The longer the plate or bigger the ball, more is the expansion for the same rise in temperature. The nature of the material being heated also plays an important role in expansion. For example, copper expands more than iron for the same rise in temperature.
Okay, so this is the third condition, the nature of the material. Copper has more ability to expand than iron. Okay.
Liquids and gases are fluids. They expand on heating. Expansion in gas is very large as compared to solids or liquids.
Good, very good. Now let's go to the next video. That was very small video, and now we want to see more things about thermal expansion. Stay focused on it.
Todo empezó como cualquier otro viaje a casa.
Have you ever rubbed metal continuously with its surface? If so, you would have noticed that metal gradually changes its shape.
Attention, when you rub two metals, you are giving them energy. In this case, thermal energy. And one of the effects of the thermal energy is the expansion of matter.
It expands, therefore, there is change in either its area, volume, or shape. Even when iron is exposed to heat, it expands. These are all the effects of thermal expansion. So, what is thermal expansion? It is a process in which a body expands in either area, volume, or shape when.
Okay, so this is thermal expansion, so where a body expands, no matter we're talking about a liquid, a solid, or a gas. Okay, so it expands in either area, volume, or shape when heated.
Heated. Thermal expansion occurs in solids, liquids, and gases. First, let's consider solids. When a solid is heated, it expands in size and shape, resulting in an increase in length, area, or volume of the solid. This is known as a thermal expansion of solids. But what makes a solid expand? When a solid is heated, the molecules that make up the solid begin to vibrate. This takes up more space and the solid matter expands. Let's see an example of expansion in solids.
This is a very interesting exercise. Okay, you are doing all time at home. You are seeing your father, your mother do it when they want to open a kind of flask here. Okay, and they can't. Okay, look what happened.
When you can't open a tight jar, it is recommended that you place it under hot water for a minute. The metal.
Hot water. Why? Because the metal will expand. And it's easier for you to open the lid of this flask.
Lid will expand because it heats up and won't be so tight anymore. Now, you can open it easily. Next, let's study thermal expansion in liquids. Like solids, liquids also expand when heated. However, since liquid particles are usually less tightly bound to other particles, they generally move further than solid particles when heated. Hence, liquid expands more than solid when exposed to the same temperature. In a thermometer, mercury is an example of expansion in liquids.
Nowadays, there is no mercury in thermometers nowadays because this is dangerous. Okay? We use alcohol instead of mercury. But it's the same thing. So when you heat this material, it expands and it rises up until a point, and you can see the temperature. Okay?
When we increase the temperature, the mercury starts to expand, and we can clearly see an increase in the level of mercury.
Mercury is a metal that is liquid. It's a liquid metal, mercury.
Finally, let us see how gases react when they are heated. Gases expand most when heated. This is because gas particles are far apart and are weakly attracted to each other. It is much easier for them to move further than solids or liquid particles when heated. Heat causes the atoms of the gas to vibrate and take up more space.
It's the effect of an explosion. An explosion, when you can see an explosion, maybe on TV or maybe in real, take care about that. You see how the gas expands, okay? And that's due to the expansion of matter in gases.
For example, the gas gauge on a car. People are much more likely to run out of gas in the summer than in the winter. Why is that? Well, the gas in your car expands just like everything else, and it changes the reading on your fuel gauge. In the summer, gas takes up more space in the tank. So, when the fuel gauge reads empty, it indicates that there is significantly less fuel left in the tank than it would be during winter. You may get an extra 35 miles after the fuel gauge shows empty in the winter, but that won't be the case in the summer heat. So, be careful. You don't have to walk 3 miles to the gas station just because you don't know about thermal expansion.
This is a good example. So people think that they have enough gas in the depot in summer, but it's the same gas. So what happens is that they think that there are more because of thermal expansion of the gas. Okay, and finally they ran out of gas. Good.
Let's summarize what we learned today. Solids, liquids, and gases expand when heated.
This is the first thing. Okay. All three states of matter, solids, liquids, and gases expand when heated. Second thing.
Thermal expansion causes an object to expand when heated. Gases expand most when heated.
Good, very good. Now, let's go back to our text part. Now, another important effect of thermal expansion is the change of state in matter. And before, you need to remember that there are three states of matter. Okay, they are called solid, liquid, and gas. And thermal energy can change the state of particles to gas, liquid, or solid. And you have here three pictures: solid, and look here, this is water. That's water inside the cup. And this is water. Okay, water, water, and water. This is solid water, and we call it ice. This is gas water, and we call it vapor water. And this is water in a liquid form. But water, the same, no matter the state. So imagine you have solid here in this water, and you can turn it into liquid. Only thing you have to do is to give it more heat, and you can change solid into liquid. You continue to warm up, to heat up this liquid. You can get this liquid to turn into a gas because of the particles, because of the movement of the particles in gas. And the opposite is true as well. You have gas and you can turn it into liquid. The only thing you have to do is to take away heat energy here. Okay, you cool down this gas and you turn this gas into liquid. And if you continue to take off heat from the liquid, you can turn liquid into solid. So from liquid water into ice, and these are called the change of states of matter. You have here a paragraph. For example, if water is cold and its molecules are moving very slow, it will be a solid ice. This part. If it warms up some, the ice will melt. This is the name with melt, and water becomes a liquid. So this process is called melting. Melting, when a solid changes into a liquid. This is called melting. That happens with all kinds of matter, not only water. Good. And if you add a lot of heat to water, the molecules will move very fast, and it will become a gas, steam. Steam is the English for our Spanish vapor, vapor. Okay, and these are the names for these changes. So thermal energy can cause liquid to change to gas, and this is known as vaporization. Vaporization. Okay, so vaporization is the change of a state from liquid to gas. Okay, let's move. And thermal energy can cause gas to liquefy, and this is called condensation. Condensation is the effect, for example, of the rain. The rain, you have there water in form of vapor, and it condensates, and finally it rains. It's the same water turns from gas to liquid. Then you have thermal energy that can cause liquid to solidify. So when you put your fridge a glass of water, and finally you go after a time to see it again, you can see it in the form of an ice, and this is called this is solidification. Finally, you have thermal energy can cause a solid to melt. The melting process occurs when a solid, such as ice, changes to a liquid water. And even you can have another two different change of states. We're going to see it then in another clip, from gas directly to solid. This is called sublimation. So let's see another clip.
Changes of state of matter. Matter exists in three states, namely solids, liquids, and gases. The change of substance from one physical state to another is called change of state.
The change of state is when you change the state from solid to liquid, or liquid to gas, or the other way around, or gas to solid, solid to gas. This is the same matter, but the change of state is the change of liquid from liquid to solid, and so on.
Change of state occurs due to heating or cooling of the substance. When a substance is heated, its molecules start moving faster and the intermolecular spaces increase. Gases expand the most, while solids expand the least on heating. Fusion or melting is a process in which
the same, fusion or melting. You can use both words. It's the same process from solid to liquid, okay, through heat energy.
a solid changes to liquid state at a constant temperature due to absorption of heat. This fixed temperature is called the melting point.
Each substance has its own melting point. In the case of water, it's 0 Celsius degrees. but each substance has its own melting point.
Example: wax melts at about 63 degrees Celsius. Ice melts into water at 0 degrees Celsius.
Each substance has its own temperature for melting, or evaporation, or sublimation, each substance. So that's why scientists need to know many things and experiment with a lot of substances to know their properties.
On application of heat and pressure, the internal energy of a substance increases, resulting in a rise in its temperature. As the temperature reaches the melting point, the molecules of the solid gains enough strength to break the molecular force of attraction, resulting in liquefaction.
Liquefaction is another word for the change of state from solid to liquid.
Freezing is a process in which a liquid changes into solid state at a constant temperature by releasing heat.
Freezing is the same as solidification. There are some synonyms. Freezing is the same as solidification. This is the process by which you have a liquid, water in a form of liquid, and turns into solid.
This fixed temperature is called the freezing point. The melting point and the freezing point is same for any substance.
But melting is from solid to liquid, and freezing is from liquid to solid. The same temperature, okay? But the direction is different. Remember, melting from solid to liquid, freezing from liquid to solid.
Example: the freezing of water liquid into ice solid at 0 degrees Celsius. When temperature is lowered, the molecules come closer to each other. Gradually, they solidify. Vaporization or boiling is a process in which a liquid changes into its vapor state.
Another synonym, vaporization or boiling. You can use both. Okay, boiling. We're talking about a liquid that turns into vapor, into steam. Oh, sorry.
At a constant temperature by the absorption of heat. This fixed temperature is called the boiling point or the vaporization point of the liquid. Example: the vaporization of water liquid into steam gas at 100 degrees Celsius. When any liquid is heated, its temperature rises until it reaches its boiling point. The temperature will then remain at that point until all of the liquid is boiled away. Condensation is a process in which vapors change into a liquid state at a constant temperature by
This is the opposite. Okay, condensation is when you have first vapor, gas, and turns into a liquid. Okay, condensation. Remember rain.
releasing heat. This fixed temperature is called condensation point. The vaporization point is same as the condensation point for any substance.
But condensation is one thing and vaporization is another different. So it's the same temperature. Vaporization is when you have a liquid turning into a gas, and condensation is when you have a gas turning into a liquid. Okay, but it's the same temperature but different process, the opposite process.
For any substance. Example: the conversion of steam gas into water liquid at 100 degrees Celsius. Sublimation is the process in which a solid directly converts into gaseous state.
Okay, you don't have this in your notes. You are going to study next year. The sublimation is the process by which you have a solid that turns directly into gas. Okay? It's not very easy to occur, but it occurs.
Example: sublimation of camphor or naphthalene. In this process, the solid does not pass through the intermediate liquid phase. The process requires additional energy. Solidification or deposition is a process in which a gas condenses directly into solid state.
This is called solidification, or this is called sublimation as well. Okay, so this is the opposite, from gas directly to solid. It's not easy to occur that.
Example: conversion of carbon dioxide into dry ice.
This is a summary. Okay, you have gas, liquid, and solid. So you have solid and go to liquid. This process is called melting. Okay, you have liquid to gas. This process is called vaporization. And the opposite is you have gas to liquid. This is called condensation. From liquid to solid, freezing. You have more words. You have more synonyms. And the direct process is sublimation. Sublimation is from solid to gas, and from gas to solid. You can call it deposition or sublimation as well. Same word. You go from solid to gas. You need to add up energy. Okay. You need to add up energy. And you want to go from gas to liquid to solid, you have to take off energy. Good. Now let's go back to our notes. So now go to your exercises. This is another exercise we need to correct. So you have here exercise number 10, page number 6. You have here state, solid, and you add up heat. So the new state would be from solid, you add up heat. New state would be, yes, liquid. An example could be from ice to liquid water. So now you have here liquid, and you continue to heat it up. So, and you can get this liquid turned into a new state that is gas. Okay. So an example could be when you put something in your oven and you see the steam. Okay, so it's called vaporization. Then you have a gas and you take off heat or put cold, and you get this gas turned into a liquid. So for example, when you put ice into a drink, after some minutes, you can see this ice turn into liquid. And finally, you have here a liquid, and you take off thermal energy. You can turn this liquid into a solid. Okay, very good. And the example, when you put in a freezer some water, and finally you have ice there. Very good. And number 11 and number 12, these are the exercises you have to do today, and these are very easy. Very good. So now we're going to finish this class. When you see teacher Javi, please greet him on my part. Very good. And now please finishing